Welcome to the deep dive. You know how your phone apps constantly update, getting new features, fixing bugs? That's traditional software, right? Super flexible.
Right. You expect that adaptability.
But then there's AI software, especially the deep learning stuff. It feels, well, different, doesn't it? Almost more like a piece of hardware kind of fixed.
That's a really great analogy, actually.
Yeah.
It captures something fundamental. We got some interesting sources that touch on this exact point.
Yeah, and so our deep dive today is all about trying to understand why. Why does AI software sometimes give off this hardware vibe?
Well, you hit on it. Traditional software is coded, line by line. Developers write explicit instructions. Hardware, conversely, it's manufactured with its function largely set.
Okay.
And AI software, even though it is technically code running on hardware, it acquires this sort of fixed nature.
Right, so it's not coded in the same way. Our sources emphasize this difference. AI models are trained. What does that really involve?
It's a completely different paradigm.
Hmm.
Instead of writing rules, you feed the model massive data sets.
Huge amounts of data.
Exactly. And you use a lot of computational power, basically, having the model adjust its own internal parameters, its sort of virtual wiring, to find patterns in that data. It's
Hmm.
learning, not just executing pre-written instructions.
So it figures out the rules itself, more or less.
That's the core idea, yeah.
Yeah.
It discerns patterns, makes connections based on the data it's seen.
And okay, this training, one source had this analogy I liked. It compared it to pouring concrete. Once it sets, you can't easily just reshape it. Does that track for an AI model post-training?
That's a surprisingly good analogy, actually.
Yeah.
Um, Once that intensive training is complete, the model's parameters, its learned knowledge, becomes relatively fixed. It's hardened, you could say.
So changing it isn't simple, not
Yeah.
like editing code.
Not at all. Making significant alterations often requires going back and doing substantial retraining, sometimes almost from scratch. You can't just, patch a specific function easily.
Hmm.
The underlying structure, the knowledge, is all interconnected in a way that was learned, not explicitly designed module by module. Tweaking one thing can have unpredictable effects elsewhere.
Which definitely sounds more like needing to replace a physical component than just updating software code.
Okay, but what about transfer learning? The materials mention that. Doesn't that add some flexibility back in?
It does, yeah. Transfer learning is it's a really useful technique. You take a model trained on a broad task, like recognizing general images,
Okay.
and then you adapt it, fine-tune it for a more specific related task, maybe recognizing specific types of birds using less new data.
So it gives you a head start.
A big head start, often. But, and this is key, the fundamental early layers of that original model, the parts that learned basic shapes or textures, they often remain frozen. They're still sort of set.
Ah, so you're adapting around a fixed core,
Mhm.
essentially. It's not like rebuilding the whole thing.
Precisely. And if the new problem is fundamentally different from what the original model was trained on.
You have to start over. Often, yes. Retraining from scratch becomes necessary, which, again, brings back that computational cost and reinforces that hardware-like nature compared to just rewriting some code.
Right. That really lands the point. The cost and difficulty of major changes lean towards hardware.
So connecting the dots here, the sources suggest that this feeling of AI being like hardware stems directly from this training process. It's the nature of how the AI learns and solidifies its knowledge.
It bakes in the understanding, making it resistant to easy modification afterwards.
Exactly. The knowledge isn't modular code. It's a complex, learned internal structure.
Okay, so wrapping this up, the key takeaway seems pretty clear. It's the training itself, the process of learning from vast data rather than being explicitly coded, that fundamentally makes AI models less flexible, more hardware-like than traditional software.
That's the essence of it. That initial intensive learning phase defines its capabilities in a way that's hard to alter significantly without more intensive work.
So we understand the why now, this sort of inherent rigidity from the training, which poses a really interesting final thought, doesn't it? Given this characteristic, what are the real implications for developing and deploying AI in fields that are just constantly rapidly changing? How to keep up if the tools themselves are somewhat fixed?
That's the challenge, isn't it? Balancing the power of these trained models with the need for agility. It's something the field is constantly grappling with.
Definitely something for our listeners to think about.